Hello, friends. A very good morning to all of you, or good evening, as the time suits you. Uh, Today, we are going to be starting with our geography class. This is our first discussion together on geography. We'll be having in and around 40 to 45 classes on geography, and I'll be trying to discuss as much as possible and to cover up the syllabus of geography for the civil services. Now, to start with, what is geography? As to what do we need to learn in geography? What are we going to learn? Because if you say geography, it encompasses a whole lot of new ideas and subject matters. But what is important and what is relevant to our course of civil services is more important. We should not be loitering in and around in the world of geography. We just need to be very precise and pinpointed at what we are going to learn. কি শিকিম আমি জিঅ'গ্ৰাফি, কি বস্তু হয় জিঅ'গ্ৰাফি, ইয়াত কি লাগে, কি থাকিব, আমি কি পঢ়িম, APSC বা UPSC কাৰণেই হওক আমি কিমানখিনি পঢ়িব লাগে, বা বহুতো কিতাপৰ নাম ক'ব, কিন্তু do we really need all those books that are being told to us to read? Yes, NCERTs are very important because the NCERTs cover a very bulky portion of the geography. For clearing the basics, NCERTs are very good. You might be coming across many PDFs of class notes. Those are also good as well, but to know if they are good enough, because there are many PDFs and many of them are fake PDFs that are not even meant for the civil services. Now, this is a business going around in the country, and being a very new to the game, you won't know it, which one is the fake or which one is the actual notes that you need to learn. So for that situation, the NCERTs provide a guide, and also they are very illustrative and very quite a bit descriptive and in detail also at times when you need it. So of course we'll be going through the NCERTs. The NCERTs are very important for geography as also for the other subjects, but the geography is very important because it covers the minute factual details that we need to know. As we go forward, we'll be discussing the NCERTs as well, along with the discussions that we'll be having here. So to start with, geography. What is geography? Now, geography is a term that it is a collaborative term of two different terms. One, we have the geo, and then we have the graphy. Now, geo means earth, prithvi, and graphy pertains to, or it tends to explain or refers to something as descriptive science. It tends to describe a thing. What is being described in geography? Geography describes the earth. But what really do we describe in earth? কি বোঝায়? Now, the very important thing is, who started to study geography? কোনে আৰম্ভ কৰিছিলে পঢ়িব জিঅ'গ্ৰাফি? কেলে লাগিছিল? Why do we need geography? Why do we need to study geography? What is the importance of geography? Now, as the history speaks of, the Greeks were supposed to be the first geographers of the world. They were the first who started on to make maps, precise or not precise, but they made maps. And they are supposedly to be the first map makers of the world. Now, in this respect, we have a very important name, and it is Eratosthenes. Eratosthenes was a Greek, and the first to coin the word as geography, and he described it as the study of earth as a home of man. He said, in the home of man, মানুহৰ ঘৰ Geographic Illustrationist College, geography whole Manohar Ghor. He described it as a home of man. Now, what is geography actually? To be, since it falls into a category of science, we need a definition. Definitions are all that we are concerned about nowadays in our. Now, what actually is geography? What is the definition of geography? Since it falls in the category of science, or rather we study geography in the science discipline, it must have a scientific approach of its definition. Now, Hartshaw describes geography as accurate, orderly, and rational interpretation and description of the variable character of the Earth's surface. Now, this is a rather very complex statement to start with. What is variable character of Earth's surface? What does it mean by the variable character? The variable character of surface means that the Earth is not flat. It has many hills, the valleys, the trenches. Its surface is variable. When you come across the hills and the trenches and the rivers and the plateaus and the mountains, but there is no one single reason for all of this. There is not a single universal reason for all of this. It has the many factors responsible for forming the surfaces, the reliefs we let us call it. And geography tends to tell us, and it tends to help us to interpret how does variable characters, how does mountains and the valleys and the rivers and the fog and the clouds and all those sorts of things happen, how the climate changes, how the climate change affects us and affects the surfaces of Earth, how it changes the flora and fauna of place, how species get extinct, the reasons, the geographical reasons of species getting extinct, and it tends to give us an accurate, it tends to give us an orderly in the sense, the phase wise, and then it tends to give us a rational approach, testified scientific approach as to why the Earth's surface changes over time, as to why there was once a Pantalasa and Pangaea, the supercontinent, the supercontinent and the super ocean, and why today we have broken continents, why the Indian subcontinent moved from somewhere around Southern Africa, Madagascar, and it moved northwards, how it collided with the Eurasian plate that led to rise of the Himalayas. The syntaxal bands, why was there syntaxal band in India? Why coal is found in Sweden? So those are the certain things that needs to be answered, and geography has a very good way to answer it. Moving on. Now, there has been many speculation regarding whether the Earth is round, is it a perfect sphere, or is it not? Now, the Earth has a typical shape of its own. It is its own shape. It is not round. It is not flattened. It is not spherical. It is what you call in geography as geoid. It resembles the shape or form of the Earth. That's intriguing. We have a shape of the Earth and we call it a geoid. Now we had circle, we get cylinder, we had rectangle, and now we have geoid. What is geoid? Geoid refers to the shape of any object that resembles the shape of the Earth. Now, what is the shape of the Earth? We'll be discussing that a bit later. Now, Who now? Who reads the shape of the earth? Who on earth reads the shape on earth? Who earth shape की? Who measures it? Why do we need to know what the shape of the earth? Why do you know how long it is, how flattened it is? But there is a department, there's a branch of science. It's a science to determine the earth's shape and the size. Shape. By surveys, they use surveys and mathematical calculations, and this is called geodesy. People, geodesy takes up mathematical calculations. In the modern era, we have come across with many algorithms that does it. That tends to determine the Earth's radius accurately as possible. It tends to follow on if the Earth's radius changes with time, spatially and temporally. Now, what is the Earth's shape? That is a nice important question. What is Earth's shape? Is it round? Who knows? Now, prior to 1687, it is largely thought and people are quite sure that Earth is round. Before that, it was a thinking in the medieval period. People thought that the Earth is flat. Then came Renaissance, and then it was found that oh no, the Earth is round. In that era, the world came across a famous person called Isaac Newton. Now, Isaac Newton was a mathematician, as you all know, and he has a lot of contribution to mathematics, physics, and he proved that the Earth is not perfectly spherical, but the Earth is slightly misshapen. Now, this term misshapen, what does it mean by misshapen? What is misshapen? It is not round, but we always hear that the Earth is round. The globe that we have in your study room, it's round, it's spherical, it's a perfectly spherical, but it is not, because Newton says so. Thing is, we believe the Earth to be round, but this is wrong. The Earth bulges along the equator. This is because of the centrifugal force. The centrifugal force tends to elongate. The centrifugal force tends to elongate the Earth along its equator and tends to throw it apart. As a result, along the equator we have a bulging Earth, and it compresses along the poles. Here, as you can see, it goes here, down here. The radius is not equal. From here to here, it's not equal. As you can see, we have 12,714 kilometers from North Pole to South Pole, but we have 12,756 kilometers. That's a difference of 42 kilometers in diameter when you go from the east to west. Now, it seems like 42 kilometers is a very large deal. But surprisingly, on this planet Earth, Earth is the most spherical object you will ever come across. There is nothing more around the Earth. Earth is the most spherical we'll ever come across on this Earth, or at least that has been manufactured till date. That's why the marble that we used to play in our childhood seems spherical. The globe that we have on table, it seems spherical too. But when these are prototypes, when we enlarge it to this extent, we come across a very huge difference, which will be much more than 42 kilometers. Here the accuracy, the loss of accuracy is around 0.03% in case of Earth, but in case of the other round objects, man-made round objects that we have, it will be quite high. So yes, Newton is right when he speaks that the Earth bulges at the equator and compressed on the poles. Well, this is 3% difference. Now let's talk about another fact: latitude and longitude. Yes, I'm sorry for this because I'm not that good in this. Well, I'm sorry for this because I'm new to this and I don't know. I couldn't actually draw these red lines, to be very frank enough. So I took a snap off from my notebook and I pasted it here. That was rather easy and time saving because all we need is to know the knowledge, not the beauty behind it. So the next big thing is the latitude and the longitude. Now, latitude, longitude. These are two very important things. It's very often we call that 10 degree north, 20 degrees south, 23.5 degree north, 23.5 degrees south, Tropic of Cancer, Tropic of Capricorn. But what are these degrees? These are not temperature degrees. What are these? So, the latitude. Now, this is the latitude. X degree north is the latitude. Now, what is this latitude? The latitude is the angular distance measured. It is the angular distance. This is the angular distance measured north or south of the equator. We can point. This is point P here. You project a line from the given point P on the Earth's surface to the center of the Earth. We project a line from the point P on the surface to the center of the Earth, and then we connect this point along the equatorial plane to the equator. We come across a angle. This angle is X degree north. Similarly, if you go down from this point, you draw a line there. From this point, you draw a right line like this, and this will be some Z degree south. So from any point, there are certain points on this Earth from where whatever you draw, line drop. So there are certain points on this Earth for which, if you draw, suppose this is the point, if you drop a line from here to the center, it will again be X degree. You drop from here, it will again be X degree. You drop it from here, it will again be X degree. So all these points, when you join these points, these infinitesimal points, there are thousands and lakhs of points here. When you join this point, we get a line. This line is called a latitude. Now, similarly, we have points here, we have points here, we have points here. So all these lines are parallel to each other. These will be parallel to each other throughout and these lines will be parallel to each other throughout. These all lines will parallel, and that is why latitudes are also called as parallels. There are three very important latitudes. One is the equator, 0 degree, north or south, we don't know. There are three most important parallels. One is the 0 degree, the second is the 23, the second is the 23.5 degree north. We call it the Tropic of Cancer. In the southern hemisphere, we have another that is 23.5 degrees south, and we call it the Capricorn, Tropic of Capricorn. These three are the very important, the most important latitudes. Moving on. Now, let's move on to another very important line, that is the longitude. The longitude is the angular distance between the meridian passing through a given point and the prime meridian, and it is measured east or west of the prime meridian. So for a reference, let's take this to be a prime meridian. What is this prime meridian? The prime meridian is that meridian which passes through the Greenwich, and with reference to this meridian we have the Greenwich Mean Time, and also we have the International Standard Time. And the angular distance, this is the line. Suppose here we are here on this latitude, on this longitude, and we move along the equator and reach point M. Now this angle y degree that it makes is called y degree that it makes, and we draw a line here. Now anywhere you move, the angle will be same. Anywhere you move, the distance covered will be lesser and lesser as you go to north, but the angle that it traverses will be the same, and hence we have a tapering longitude. Unlike the latitude that we have parallels, longitudes are tapering because the earth tapers to the north and to the south pole. Hence it tapers, the longitude also tapers, but the angle that it makes is always the same. Let's move, like if you look at for top view, angle is always the same. The angle is always the same here. The distance is shortened. If you look it from up here, it will look like this. The earth will look like this. This is the point L, this is the point M. This is on the equator, and suppose this is one, this is say x1, and this is say x2, and this one will be x1 and this one will be x2, but the angle will be same. Hence we have the latitude. It's parallel, but longitude will be tapering. So if this is the Greenwich Mean Time, that is a standard that passes through Greenwich, adding to the east of it will be marked as x degree east, and anything to the west of it will be marked as y degree west. Now for every degree that moves, okay, we'll have a separate class, we'll have a separate discussion on it. I suppose we're clear to this point. Non-important parallels. The important parallels. As we can see, this is the 0 degree, and 0 degree is the equator. This is the equator that divides, the equator is a latitude that divides the earth into two equal halves. Upward is called the northern hemisphere, the lower part is called the southern hemisphere. So now we are going to discuss the most important parallels. As you can see, the 0 degree is the equator and it divides the earth into equal halves. The northern part is called the northern hemisphere and the southern part is called the southern hemisphere. Now moving on, 23.5 degree north and 23.5 degree south. These two are the most important latitudes that we have to know, and these two latitudes plays a very significant role in the climate control of the planet Earth. Now, this is the equatorial region. The equatorial region largely it covers the region from 10 degree north to 10 degree south, but that is not fixed. In some places it may go for plus minus 2 to 3 degrees because somewhere you will come across ocean, somewhere there will be continent. So the land masses also affect the environment. So basically we can say that 10 degree north and 10 degree south is of the, that is 10 degree north of the equator and 10 degree south of the equator, all the region that will largely be called as the equatorial region. This will feel, here we will be having sun rays. Now lastly, 10 degree north and 10 degree south we will call the equatorial regions, and this is the region that will be covered with clouds and will receive lesser sun ray in comparison to the tropical region. And this is surprising because the sun will be here, but we'll be having more heat here and less heat here, because of it will be, this part will receive immense heat and it will form clouds all over this region, and it will always be covered with clouds, and there will rainfall in this part of country, in this part of the world every day at around 4 p.m. and it is called the 4 p.m. rain. It's called a 4 p.m. rain. So now this is the Tropic of Cancer and this is called the Tropic of Capricorn. Okay. So why is it called a tropic? Why it is called a tropic? What is the meaning of tropic? Tropic means to return. Return. So this is the point and this is the point, that is Tropic of Cancer and Tropic of Capricorn. These two are the point between which the sun moves apparently with respect to the earth. Now this is a rather very tricky situation which I'll be explaining later, why the sun moves between just these two. For now, just we could remember that these are the two tropics, or the two parallels between which the sun moves apparently with respect to the earth. Above it, now this region is called a tropical region. This is the tropical region. Similarly, in southern also we have it. This is a tropical region. This is called, should write it here. This is called tropical region. This is the equatorial region, this is a tropical region, and just above a tropical region. Now from 23 to 66, 23 to 66, this is another region. From 23 to 66 degree, this region is called as the temperate region, and here we have the polar region. No. Okay, after temperate region, we have the subtropical region that lies between 23 to 40. This special part is called, the overall it is called a temperate region from 22 to 66, but from 22 to 40, 22 to 40, I'll rather go for a marker here. This entire region, sorry. This region is called, this region is called the subtropical region. 23 to 40 here, we also have a 22 to 40. And this region is called a subtropical region. From 23 to 40 it is called subtropical region. Let's come down and we have it in writing. Yes. The equatorial region lies between 10 to 14 degree, 0 to 10 degree. Okay, here we have. The equatorial region lies between 10 to 0 to 10 degree. The tropical region lies between 10 to 23 degree and 23.5 degree north and south. The subtropical region lies between 23.5 to 40 degree north. The temperate region lies between 23.5 to 66 degree and half degree north and south. And then we have the polar region. Now moving on, weather and climate. What is weather and what is climate? Do they have any difference? Yes, they do. The weather refers to a short-run atmospheric conditions involving heat, moisture, and the moments for a given time in a given specific area. What is climate? Climate refers to the aggregation of atmospheric condition involving heat, moisture, and the motion over a long period of time and over a larger area. Weather is involved with a small area of a small period of time, and climate refers to a larger area, a large period of time. When we say today's weather is beautiful, we don't say today's climate is beautiful. What to say about, like, normal context, what to say? So how is today's weather? And we say no, today is very hot, it is very rainy, whatever it could be. We don't say what is today's climate. No, the climate is, it refers to the long term, large area. We'd say how is climate of Europe? We'd say how is the climate of United States? Someone say yeah, it's varying. United States, you go to Texas, Florida, it's warm. You go to New York area in the cold, it will be snowy. It's different. Someone from United States will be asking how's India's climate, and everyone will be going, oh, it's rainy and it's hot. That's not exactly the description. Now, moving forward, there is another description of the earth. Now, the Greeks, the original geographers of the world, they divided the world into three parts: the torrid, the temperate, and the frigid. So this is supposed to be the warmer part. This is the moderate temperature, and this is cold temperature. But the very interesting fact is that though they used to call it the temperate, and even today we call the middle latitudes as the temperate latitudes, temperate, but it is not actually temperate. The temperate here is a misnomer. The temperate is a misnomer, because these middle latitudes have the maximum variability of weather conditions of the world. Maximum variability of weather conditions of the world. Maximum. We don't have such variability in weather in India. It's sunny or it's rainy or it's cold, but if you watch those English movies or Hollywood movies, and especially those movies that those are shot in the European continent, maybe James Bond and all, the European context, you'll see that a guy is putting on a t-shirt and then he has got a leather jacket on him. I used to wonder why the hell on earth do they put on such a dress? Like you put on a t-shirt, half t-shirt, and then you put on leather jacket. This is especially because in the temperate regions of the country of the world, that's the European climate, in the summer it so happens, or even in the autumn or spring, it so happens that suddenly there is very scorching heat. The sun is burning, and then you need to be in your t-shirt, and suddenly you'll see that it has the sun has just vanished into thin air, and now you are feeling cold and it's about to rain, and then again the sun comes out. So the people out there needs to ready all the time, and because of that they put on the leather jackets, or they have jackets, or they have umbrellas when they go out even though it's not raining, because you cannot be certain of what happens. It might rain any moment, it might be sunny any moment, and that is why, though we call it a temperate region of the world, that it means that the temperature needs to temperate, that it's bearable, it's beautiful. Temperate, that is what we mean when we say temperate. It's nice, it's soothing, but actually it is not. It means normal. It has a very high weather variability conditions, and you cannot be sure that yes, today it's going to be nice weather. No, it's not. Now, there is a topic called great circles. What great circles? What is a great circle? Now, any plane that is passed through the center of a sphere bisects that sphere and creates a great circle where it intersects the surface of the sphere. For example, let us take the Earth and we bisect it. Any plane, now this is a plane that has bisected the Earth. Now this plane has bisected the sphere. Now that is what it means, that any plane that is passed through the center of a sphere and it bisects the sphere and it creates a great circle. Now along this bisect we will find a great circle when it cuts it. I hope I can get to you. So when you're cutting it slice, when you're cutting it in two halves, we'll get one part will look like this, and then we'll have another part like this. This is the great circle. This is the great circle. This is the great circle. Now what is this? This is, in case of the Earth, this is the equator. Sorry, my handwriting is pathetic. Let's see. This is the equator. This equator cuts according to part, and this equator is a great circle. It is the largest circle that can be drawn on the surface of a sphere. The meridians or the longitude that we have, they make a semi-great circle, because when we are speaking of the meridians, they come from here and they end up here, so they form a semicircle. Because if this is 180 degree, opposite of it will be 0 degree. So that's a different meridian and this is a different meridian, so this meridian makes a half great circle, not full. Now when the sun illuminates one half of the earth at any given moment, the edge of the sunlit hemisphere is called a circle of illumination, and it is also a great circle. This circle of illumination divides the earth into two halves. Of course, that circle of illumination will be at an inclination of 20.5 degree to the vertical because of earth inclination, but Next topic that we are facing here is a global heat imbalance. It's a global heat imbalance. It is the global heat imbalance. Now, what is global heat imbalance? We have global warming, I know that. What is global heat imbalance? How is it imbalance? Now, when we have the sun shining, say this is the sun, should have it in red. This is the sun that we have. This is sun, and this is giving away all the rays. And these rays, when they fall on the earth, since we are drawing it here, but actually when it falls on the earth, it doesn't cover the entire stretch. The heat is more concentrated in this region of the earth. Between 35 degree north and south, the heat is concentrated, and the rays of earth doesn't get that much of heat as this portion receives, and because of which we have the polar cold area at the top and the bottom. Now, if this heat is received here and is less received here, this part will tend to be colder and colder, and it will become unheat. Now, if the heat is received here over and over again, and this region doesn't receive heat, then both this region will become too cold for any human to survive, and this region, if it continues on receiving heat continuously, these two will have an unbearable temperature, and as a result humans cannot survive in such a situation. But surprisingly, the temperature here is not that high and the temperature here is not that low. How does it happen? Here we have heat surplus in this central area of the world, and at the top and the bottom area we have heat deficit. Beyond the 35 degree north and beyond 35 degree south, we have heat deficit, and here we have benefit, surplus. So what actually happens is that heat that is being received here, the insolation that is received from the sun in this portion of the world, are being carried over to the other portions of the world by various agents. Now, there are agents that carry this heat over to the other portion of the world, and it has been dissipated across the entire world in a rather uniform manner, so that the world becomes a habitable planet. Two most important agents or ways of heat dissipation. One is the atmospheric circulation. Now, the two ways of heat dissipation, or the agents through which the heat is being dissipated from the center of the earth, that is from the equatorial region and the tropical region, to the temperate or the polar or subpolar region, the north and the south, beyond the 35 degree north and south. And the two agents are atmospheric circulation and ocean circulation. The ocean circulation carries over 20% of the heat, and the rest is carried by the atmospheric circulation, which doesn't seem possible, but it is the reality. The atmospheric circulation carries about 80% of the heat from the central part of the wall, that is from below the 35 degree north, that is from 0 degree to 35 degree north and 35 degree south, to beyond 35 degree north and south. And in this way, the world becomes a rather habitable place. So, the next thing that we have come across is longitude and time. How is time related to longitude? How we calculate the time? We say that we have different time zones, we have different times. If we are 8 p.m. in India, it must be something around 2 p.m. in the United States, whereas maybe Australia have already entered the next day. But how does this happen? How do we calculate it? Now, to calculate it, suppose this is one latitude T1, Suppose this is one longitude T1 and this is another longitude T2. This is one longitude T1 and this is another longitude T2. T1 and T2. And suppose we have India here. This is longitude passing through Gujarat and this is something passing through maybe Odisha. Okay. So what will be local time here? So the mathematical thing is, if this distance between the two longitude is x degree, and suppose this was a T1 time in say latitude x degree and y degree, suppose west. So x degree west and y degree west, they have a this isn't possible. Suppose we have longitude 1 and longitude 2. Longitude 1 corresponds to time T1, longitude 2 corresponds to time T2. Now, how do you calculate it? So see, anything to the east we'll have to add time, and anything to the west we'll have to subtract the time. But by what factor? The factor is 4. For every degree movement to the east, the time moves ahead by 4x. For 1 degree movement to the east, the time moves by 4 minutes. Suppose there is one place which is at say 20 degree east, and there is another place which is at 30 degree east. Suppose time here is 2 p.m. we have a 10 degree variation, that will be 40 minutes now. Plus 10 into 4 will give us 40 minutes. So this place will be 2:40 p.m. When this place will be at 2 p.m., this place will have a local time of 2:40 p.m. Now let's talk about local and standard time. What is local time and what is standard time? The Earth completes one rotation in 24 hours. That is, Earth takes 24 hours to move by 360 degrees. Now, the local time at a place is fixed with reference to the part of the sun in the sky. It is a 12 noon local time when the angle of inclination of the sun is maximum at that time. Now, the local time at a place is fixed with reference to the part of the sun in the sky. It is a 12 noon local time when the angle of inclination of the sun is maximum at a particular point. At that time, sun is crossing the longitude at that point. The very interesting is that all places of a given meridian will longitude have the same local time. It will have the same local time. Term meridian refers to a moment of a day when the sun is highest in the sky, that is 12 noon. Now, let's talk about the standard time. Well, before the middle of the 19th century, hundreds of different time systems were in place throughout the world, and it were basically based on the rising of the sun. Now, the late 18th century, late the 19th century was a time when the British Empire was expanding its limbs all across the world, and in such a situation, they had to have a standard time all across their colonies everywhere, because it was creating a lot of confusion in it. Like, their colonies expanded from the America to Australia, and it has a varied time zones. So there was a very famous personality in the time by the name Sir Stanford Fleming. But Sir Stanford Fleming led a fight in Canada for standard time and for an international agreement upon a prime meridian. He called on for a prime meridian, that we needed a prime meridian. And his struggle led to US and Canada to adopt a standard time in 1833. The standard time now Sir Stanford Fleming's fight led to Canada. Now, Sir Stephen Fleming's fight led to Canada and US having a standard time. In 1884, the International Meridian Conference was held in Washington, D.C. In 1884, we had the National Meridian Conference in D.C., Washington, USA. Now, to avoid confusions, we follow uniform time throughout the country or region. As in India, we have the same time that we have in Arunachal Pradesh, the same time we have in Gujarat. Now, such uniform time is based on the central meridian of the country or the meridian on which the most important city is located. Such a central meridian is called a standard meridian. For India, we have it as 82.5 degree east, and it passes through a place called Mirzapur near Allahabad, or as people today call it, Prayagraj. Now, in India, we have only one standard time that is based on the longitude passing through 82.5 degree east. But in many other countries, we have multiple time zones, and this usually happens in countries that are very wide and big. Because in such situations, we need to, like, it encompasses a very large area. For example, Russia. Russia has a very large area, so Mongolia, it has a wide extent diagonally, or like it is a wide extent from east to west, and because of that, these countries function better when they have multiple time zones. And multiple time zones have been a topic of dispute in India also, because the sun rises in the northeastern states of India quite early, and actually, sunrise in the northeastern states is around 2 hours earlier than when it happens in Gujarat, and so is sunset. So there is a lot of time loss and high energy consumption in northeast because of this particular lag that we have been facing. And there have been discussions over academics and also in the political level for creating a new time zone for the northern states, like the one we have in the tea gardens of Assam, called the Bagan time. It's called a Bagan time. Time is busy not. We'll be coming back to that later. Now, what was decided in that 1884 conference, International Meridian Conference? What was so significant about it? Now, it seems like few straight lines out there, but yes. Now, what was decided in 1884 conference? The world was divided into 24 time zones, each extending over 15 degree latitude. Now this is the 0 degree, 15 degree, 30 degree, 45 degree, and this would continue until it reached 180 degree. And the same matter, it moves this way. This is the world, move this way, and then it moved this way. This 15, 30, 45, 60, 75, and it moved until 180. And this 15, 30, 65, 45, 60, 75, and then moved to 180 west and 180 east. This 24 standard time zones were created. The local solar time of the Greenwich Mean Time was chosen as a standard for the entire system. The local solar point of Greenwich Mean. Why was Greenwich Mean taken up as a standard? Because of their monopoly in those days. Because, as we know, England and Great Britain was the powerhouse of entire world at that period, and whatever they say was to be obliged by the entire world. And so Greenwich is the center with 0 degree, no other reason for that. The prime meridian became the center of a time zone that extends 7.5 degree, and this is the 7.5 degree. Its prime meridian became the center of a time zone that extends 7.5 degree to longitude, both to the west and the east of the prime meridian. Similarly, the meridians that are multiples of 15, both east and west of the prime meridian, were set as a central meridians for other 23 time zones, each of which is 15 degree of longitude in extent. We have here a 15 degree extent. This was a 0 degree, this is a 45, 15 degree, this is a 30 degree, and these are all the central meridians, and they had an extent. Now 12 zones to the east of Greenwich Meridian, that is this 12 zones this way. The 12 zones to the east of Greenwich Meridian were designated to be ahead of the time at Greenwich Mean Time and by 1 hour per zone. That is 1 hour per zone. So this way we have 12 hours ahead, and this way we have 12 hours behind us. Similarly, the 12 zones to be west of the Greenwich Mean Time or behind. In international waters, however, the time zones are shown exactly 7.5 to the west and 7.5 to the east and west of central meridian. On land areas, however, the actual eastern and western boundaries